Welcome to this video all about cumulative frequency curves and box plots. So remember, the PDF of all the questions, clues and solutions can be found on MathsUpgrade.co.uk. The first set of questions here are all non-calculated questions. We're given some information about the heights of 80 girls there, and we're asked to draw a box plot. So first of all, you can notice that the scale has been given along the bottom there, and there's no vertical scale, since you don't need a vertical scale for a box plot. So it doesn't matter sort of how high you draw the box plot. So the first thing I'm going to do, I'm going to plot the lowest height, the least height, which is a 133. So I'm going to be plotting that about there. Then I'm going to plot the greatest height at 170, which would go there. The lower quartile is given as 145, so that's there. The upper quartile is 157, which would go there. And the median is 151, which is there. Then I'll just join the lowest and the greatest to the low quartiles with these horizontal lines there, and I draw the box in the middle between the three middle plots. Now you'll notice that I've just marked on here that this is a quarter of the data, this is a quarter, this is a quarter, and this is a quarter. You don't need to do that in your exam, and you don't need to label these either. Since this is the convention, we always know that the lowest value will go on the left, the highest will go on the right, the lower quartile and upper quartile are either side of the median. So that question there is worth 3 marks. In part B, I'm asked to work out an estimate for the number of girls with a height between 133 centimeters and 157 centimeters. Well, if you look back at the box plot here, 133 is here, that's the lowest value, and 157 was here, the upper quartile. That represents 1 quarter, 2 quarters, 3 quarters. That's 3 quarters of all the people in that survey. So that's 3 quarters of 80, and 3 quarters of 80 is 60. That's 60 there, and that's 2 marks. In question 2, I'm asked to plot a box plot from this data here. What you'll notice from this data is I'm not given the greatest height, but since I know that the range is the greatest, subtract the least, I'm going to find the greatest by just adding those 2 values together. And similarly with the upper quartile, I can just add the lower quartile with the interquartile range. That gives me this box plot here, and that's 3 marks. The next part of the question, it gives me another box plot, this time for a group of year 7 girls. So this top one was for year 11 girls, this bottom one's for year 7 girls. And it asks me to compare the distribution of heights of the year 7 girls with the distribution of heights of the year 11 girls. So when these sorts of questions, you need to compare the median and the interquartile range. Don't compare the range, since the range is not a good measure of distribution. The interquartile range is far better. First of all, the median. So if you look at the median for year 11 girls, the median was 165, and the median for year 7 girls was 158. So you can say that since the median height for year 7 was lower than year 11, the year 7 girls are shorter on average. So that's explaining it in real life. So what that actually means in real life, the year 7 girls are shorter on average. And look at the interquartile range. The year 7's interquartile range is greater than the year 11's interquartile range. That means that the year 11 girls' height is less varied. The year 7 girls, the difference between the lowest quartile and the upper quartile here is a larger difference between the differences here. So you can see that year 11 girls are less varied in height, year 7 girls are more varied in height. So always with these types of questions, explain what it means in real terms, in practicality. So that's 5 marks for that whole question. In question 3, we're told that Ben has played 15 games of basketball and we're given the raw points he scores in each game. So we need to draw a box plot for that information. We can already see here the lowest score, his minimum score was 17, and his greatest score was 28. But what we don't know is we don't know the lower quartile, the median and the upper quartile. So we need to work those out. To work out the median, you need to look at how many values there are here, and there's 15 values. You need to find the middle value. You can do that by just crossing off the smallest and the greatest, and the smallest and greatest, and keep doing that till you get to the middle. But a quicker way is you look at how many scores there are, and there's 15 scores, add 1, and then divide by 2 to get the position of the middle score. So if I do that, if I do 15 add 1 divided by 2, that's 8. So I need to find the 8th value. The 8th value is 1, 2, 3, 4, 5, 6, 7, 8. So there's the 8th value. I can check from this side. 1, 2, 3, 4, 5, 6, 7, 8. So 22 is definitely the middle score. So that's a median. Right. In a similar way, I can find the lower quartile by doing 15 add 1 and then divide by 4 to find a quarter of those 15 games. And that's going to be the 4th value. So 1, 2, 3, 4. So the 4th value is here, and that's a lower quartile. That's 18. The upper quartile is a 3/4 value. So that's going to be the 4th value from the top. So 1, 2, 3, 4. That's 26. So the upper quartile is 26. So we've now got the minimum value, the lower quartile, the median, upper quartile, and the greatest value. We can now plot that as a box plot. So this is what we'd get. Notice I put a scale along the bottom there. So choose a sensible scale. Try and use the maximum width of what's given to you. So I've gone from 17 to 29, and then that fits a box plot on nicely. The next part of the question, Sam plays in the same 15 games of basketball. The median number of points that Sam scores is 23. So straight away you can see Sam scores a slightly greater median. The interquartile range is 12 for Sam. Well, for Ben, the interquartile range was 8. Since 26 take away 18 is 8. So Ben's interquartile range was smaller. The range of Sam's points is 20. The range of Ben's points was 28 take away 17, which is 11. So Ben had a smaller range. Who is more consistent at scoring points, Sam or Ben? So for this question, consistency is all about the range and the interquartile range, not about the median. So you can ignore the median in these questions. Since we've already explained that the range for Ben is lower than the range for Sam, and also the interquartile range for Ben was lower than that for Sam, that indicates that Ben's scores are more consistent. Ben's scores are more closer together. So he's the more consistent scorer. He's not necessarily the highest scorer, he's the more consistent scorer. So that there would be 5 marks for the whole question. Question 4, we're given a stem and leaf diagram that shows the ages in years of 25 different people. So we're told the key here, 1, 7 represents 17 years. So this is 17, this number would be 18 and 19, etc. So I need to draw a box plot for that information. So remember, for a box plot, you need the minimum value, which in this case is 17, the greatest value, which in this case is 41, and you also need the lower quartile, median, and upper quartile. To find those values, we're going to find the number of values here, which we're told is 25. We're going to add 1 to give 26, and then we're going to divide that by 2 to get the median. So the 13th digit here will represent the median value. So the 13th digit is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here's the 13th digit. That 8 represents 28. So 28 is the median. To find the lower quartile, we're going to do the number of values, 25, add 1, divide by 4. That will be the 6.5th value. So 1, 2, 3, 4, 5, 6. Here's the 6th, here's the 7th. So halfway between them is 23. 23 is the lower quartile, and the upper quartile is going to be the 19.5th value, which is 32.5. Is here, 32.5. So now I've got those values, I can plot the box plot. So here's the box plot since the scale is already given. Remember, it doesn't matter how high you draw this box plot, the height doesn't matter at all, since there's no scale on the vertical axis there. The next part of the question tells us that one of the people is chosen at random. What's the probability that the person is 30 years of age or older? So we just look at how many people are 30 or older. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 people out of 25 altogether. So that will be 10 over 25, and that's 2/5 when you cancel that fraction down. In part B, we're given a group frequency table about the ages of a different group of people, and then underneath we're given a cumulative frequency table for that information. We need to explain what's wrong with this cumulative frequency table. So what you notice here is that the age for the first group goes from 0 to 20, and then for the second group it goes from 20 to 30. But in this cumulative frequency table, you should go from 0 to 30, and then this one should go from 0 to 40, and this one from 0 to 50. So these limits here, these lower limits of these three groups here, are all incorrect. They should all start at 0. So that's what I put here. The lower limits for the group should be 0. The whole question there was worth 6. In question 5, we're presented a cumulative frequency graph for the number of minutes trains were delayed. We're also told that the shortest delay was 0 minutes and the longest delay was 42 minutes. On the grid here, we need to draw a box plot for that information. So you can see the scales already drawn here for the box plot. So we need to identify the shortest and longest delays, which is here in this information here. So we can quite simply plot that as 0 and 42. And the other thing we can do is we can find the lower quartile, median and upper quartile. We can do that since we know that there's 48 values altogether. Right, since we're told in the question there's 48 trains. So there's 48 values altogether, then we know that the middle value, the median, must be at 24 values. So we can go across from 24 values, and when you reach your curve, go straight down with a vertical line and read off the value there. So that's 10. So the median here should be 10. Then, to find the lower quartile, well, a quarter of 48 is 12. So go across from 12, straight down, and you can read off that value there, which is going to be 4. And similarly, 3/4 of 48 is 36. So go straight across from 36 and straight down, and that value there is 20. So when you plot your box plot, you'll get this. Now the second part of the question gives us some information about delays on a different day. This is on Tuesday now. So here's the box plot for Tuesday. We need to compare the distribution of the delays on Monday with the distribution of delays on Tuesday. So what we're going to talk about here is we're going to talk about the median and the interquartile range. The median gives us a direct comparison of sort of the middle train, and the interquartile range tells us that overall how consistent were the times. In other words, the reliability of the trains. So you can see, because the box plots have got the same scale, right, you can directly compare them. So this box plot here, the median for Monday, there's a longer delay on average for Monday than there is on Tuesday. Tuesday's median was 9, Monday's median was 10. So that's the first thing I've written here. The median was slightly lower on Tuesday than Monday. On average, trains were less late on Tuesday. So this sentence here is important because it gives you, in real life, the impact of that. So trains were less late on Tuesday. The second thing I've commented on is the interquartile range. Interquartile range is the upper quartile subtract the lower quartile. So the upper quartile was 20, lower quartile was 4, given from these values here. And so the interquartile range is 16 for Monday. Whereas for Tuesday, the interquartile range we can see is 17 minus 6, which is 9. So the interquartile range was 16 for Monday and only 9 for Tuesday. So interquartile range was greatest on Monday, so Monday's trains are overall less reliable. Monday's trains vary more in the amount of delay that they give. They vary more. Tuesday's trains were more reliable generally from that interquartile range there. That's 2 marks. In part C, Mary says the longest delay on Tuesday was 33 minutes. This means that there must be some delays of between 25 and 30 minutes. Is she right? Give a reason for your answer. Well, we know that there's definitely a delay of 33 minutes. That was the longest train, right? And that's indicated here. That doesn't necessarily mean there's delays of between 25 and 30 minutes. There may be no data values here at all. There may be lots of trains which are in this delay region here. So that's what I've put in my answer. Mary is not right. There was definitely a train 33 minutes late, but without the original data, you cannot say exactly how late the other trains were. There may have been delayed between 25 and 30 minutes, but there may not have been. The whole question there was worth 6 marks. In question 6, we need to match the shape of each cumulative frequency graph with the box plot. So you're presented with 4 cumulative frequency graphs here and 4 different box plots. And we need to put the letter of each box plot into this table here for 2 marks. So it can be sometimes difficult to match each data set to each box plot. What I'm going to do is I'm just going to find the upper quartile, median and lower quartile of each curve here to help us to understand what each shape means. So the median for each is given by the total cumulative frequency, which is 30 for each, divided by 2, and then going across from that value and then down and reading off the value. So for this median here, this median you can see is directly in between the lower quartile and the upper quartile. We don't really need to know the exact value here. We can just see the lower quartile, median, and upper quartile are at roughly equal distances from each other. For this one here, you can see the median is first of all slightly less than it is for A, and the lower quartile and upper quartile are closer together than they were in A. For C, the lower quartile, median, and upper quartile are all close together and they're greater than they were for A. And in graph D, the median is the same as it was for A, but the lower quartile and upper quartile are quite spread out. What that means is graph A would most likely match graph Y. It would match graph Y since the lower quartile, median, and upper quartile are fairly close together. They've got a fairly narrow interquartile range. So graph A would match box plot Y. So that's what I've put in my answers here. Let's look at graph B. Graph B, the median is quite low, and lower and upper quartiles are quite close together, and they're also quite low. So graph B would match with box plot X. It's got a lower median than A, so you can see it's further to the left, and you can see the lower and upper quartile are closer together than they were for A as well. So that's box plot X. For graph C, you can see the median is greater than it was for A, so the median is going to be more to the right hand side, and the upper and lower quartiles are still fairly close together, so that would correspond to Z. So graph C would be Z. Lastly, that just leaves graph D, and that matches with box plot W, since the median is the same as it was for A, so it's in line with that one there, but the lower and upper quartile are quite far apart. It's got a wide interquartile range, so correspondingly the box plot looks very wide in terms of where the lower and upper quartiles are. So there's your answers for that question, and that would be 2 marks. In question 7, I'm given information about the times in minutes taken by 40 people to complete a puzzle. So I'm already given a cumulative frequency table here. I need to draw a cumulative frequency graph. So it's just a matter of plotting the cumulative frequency in this column against the upper limit of the group for time. So for example, 5 would be here, and 40, which is the upper limit for that group, would be here. So the first cross I'd put here. So if I do that for each one, plotting this in the X and that against the Y, I'd get a curve like this. What I now do is I then use a graph to find an estimate for the interquartile range. So the interquartile range is the upper quartile subtract the lower quartile. Since I know this 40 value, since it tells me at the top of the question here, I know that the lower quartile is going to be given by a quarter of 40, which is 10, going across to my curve and reading off the value of the bottom axis, which for mine is 43. Similarly, the upper quartile, I need to find 3/4 of 40, which is 30, going across from 30 and straight down, reading off the value, which on mine is 67. The interquartile range is the difference between the upper quartile and the lower quartile, which is 67 minus 43, which is 24 for 2 marks. In the last part of the question, I'm told that one of the 40 people is chosen at random. I need to use my graph to find an estimate for the probability that the person took between 50 minutes and 90 minutes to complete the puzzle. So between 50 and 90 minutes, so the minutes is along the bottom here, so I need to go up from 50, go across and read off how many people represented 50. So that is about 13. Similarly for 90, so 90 minutes was 37 people. If I then subtract those, that'll give me an estimate for the probability that number of people took between those minutes. So subtract those and I get 24. So 24 people took between 50 and 90 minutes. Now the probability is given for the number of people between 50 and 90 divided by the total number of people. So that's 24 divided by the 40 people in total. If I divide those through and simplify it as a fraction, I'll get 3/5. And that will be 6 marks for the whole question. In question 8, we're given the cumulative frequency table about the time it takes in minutes for Jane to go from her home to a school each day last term. So we need to draw a cumulative frequency graph for that information. So quite simply, we need to plot the cumulative frequency against the upper limit for each group here. So we'll be plotting, for example, 0 against 10, 7 against 20, and so on and so forth. So this is what the cumulative frequency graph would look like. Jane expects that it should take her X minutes to go from her home to a school each day. On 25% of the days last term, Jane took longer than X minutes to go from her home to a school. Use your cumulative frequency graph to find an estimate for the value of X. So first of all, let's look at this 25%. This is the same as a quarter. So in essence, we need to find the quartile, which represents the longest quarter to go from home to school. That would be the upper quartile. The upper quartile, the position of the upper quartile from 80 values is the 60th value, since 60 is 3/4 of 80. So the upper quarter is here. So if I was to read off the value, which is the same as the upper quartile, that will give me the value for X. If I read off here from 60 straight down, that gives me 38 minutes. So the answer here for 3 marks is 38 minutes. The remainder of the questions in the booklet are all calculator questions. So in question 9, we're given a box plot and we're given some values for the minimum, lower quartile, median, upper quartile and range. We need to describe 2 things wrong with the box plot. So the first thing you can see is the median is plotted as 30, but it should be 32. So that's the first thing. Another thing that's wrong is that the maximum is plotted as 55, but from this data here, we know that the maximum is given by the minimum plus the range, and that would be 67. So they've plotted a range here instead of the actual maximum value. The whole question there was worth 2 marks. In question 10, we're told that Megan grows potatoes. The box plot below shows information about the weights of her potatoes, and she says that half her potatoes weigh less than 50 grams each. We need to give a reason as to whether Megan's correct or not. So first of all, half the potatoes would be the median value. So from her box plot here, the median value is given as 57. So if 57 is the median value, 57 grams, that means that she's incorrect, since she says that half of potatoes weigh less than 50 grams. In actual fact, half of potatoes weigh less than 57 grams, and half of them weigh more than 57 grams. So that's your answer there for 1 mark. The next part of the question tells us that Amy also grows potatoes, and we're given a box plot for Amy's potatoes on the next page. So from this you can see straight away that the median for Amy's is 42, so it's lower than Megan's. We can also find the interquartile range by doing the upper quartile subtract the lower quartile, which gives us 16. We need those numbers since we're going to compare the distribution of Megan's weights compared to the distribution of Amy's weights. So we can say that Megan's potatoes have a greater median than Amy's, so therefore Megan's potatoes are larger. So we're relating that to real life. Also, we can see that Amy's potatoes have got a much shorter interquartile range. Right? So since Amy's interquartile range was 16 and Megan's interquartile range was 26, that means Amy's potatoes are much closer together in terms of their weight. They're more consistent, so they're of a more similar weight. So that question there is worth 3 marks. In question 11, we're given a box plot showing distribution of weights of Tom's tomatoes, and we need to work out the interquartile range. So the interquartile range is just the upper quartile subtract the lower quartile. The upper quartile here is given as 166 and the lower quartile is 158. So if I subtract those numbers, I'll get 8 as my interquartile range. In the next part of the question, I'm told that Jack also grows tomatoes. So I'm given the weights in grams of his 15 tomatoes and I need to draw a box plot for that information. So first of all, I need to find the minimum, lower quartile, median, upper quartile and maximum, and then I can plot those on the grid. The median is just given by the middle value. There's 2 ways of finding this. You can either cross off the lowest and cross off the greatest and keep working your way in towards the middle, or a much quicker way is to recognise there's 15 tomatoes here. If I add 1 and divide by 2, that gives me the position of the median tomato weight. So 15 add 1 is 16 divided by 2, so the median is given by the 8th position here, the 8th value. So that is 1, 2, 3, 4, 5, 6, 7, 8. Or from this side, 1, 2, 3, 4, 5, 6, 7, 8. So the median is definitely 170. The minimum is 153. The maximum is 186. Now the lower quartile and upper quartile can be found in a similar way to the median. The lower quartile is the quarter position, which here would be the 4th position. So 1, 2, 3, 4. And the upper quartile would be the 4th position from the top. So 1, 2, 3, 4. So lower quartile is 164, upper quartile is 175. When you plot that, you get this box plot here. The last part of the question is worth 2 marks, and it asks us to compare the distributions of Tom's tomatoes with the bottom one, which is Jack's tomatoes. So I can just compare this box plot with the box plot underneath it. If you look at the scale, look at the axes, they're exactly the same position. So what that means is I can just compare just by looking at them, since they're horizontally, they're at the same position. First of all, you can see I need to compare, if I compare the median for Jack's tomatoes, this bottom one here, the median is greater. The median here is 170, the median for Tom's tomatoes is 162. So Jack's tomatoes are slightly heavier on average. That's the first thing. I'm relating it to the real life, which is the weight of the tomato. The second thing I want to comment on is the interquartile range. The interquartile range for Tom's tomatoes was 8, and the interquartile range for Jack's tomatoes is the upper quartile subtract the lower quartile. So that was 175 subtract 164, which was 11. So you can see that the interquartile range for Tom's tomatoes was smaller. So Tom's tomatoes are of a more similar weight. Their weights are much closer together. You can see that from the distance, the width of the central part of the box plot. The width there is narrower than this width. That means the tomatoes here are much closer together in terms of weight. The whole question there was worth 6 marks. In question 12, I'm given the box plot showing information about the distributions of the amounts of money spent by some male students on their holidays. I need to work out the interquartile range for the amounts of money spent by those male students for 2 marks. The interquartile range is just given by the difference from the lower quartile to the upper quartile. The upper quartile is 330, the lower quartile is 150. If you subtract those amounts, you get £182. The next thing I need to do is I need to draw a box plot for information given in this table. This is the amount of money spent by some female students. So I'm told the smallest is £60, so that will be the minimum value there. The greatest is 650, So that's the greatest value there. I'm told the lower quartile, median and upper quartile, so I'll just plot those in the central part there and join them with a box and draw the whiskers. In the next part of the question, Chris has made a comment saying that the box plots show that the female students spent more money than the male students. We need to say whether Chris is correct, giving reasons. So what you can see is that the median for the female students was greater than the median for the male students. So that would suggest that females spend more on their holidays than males. But you can also see that the male student that spent the most spent more than the female student that spent the most. So I'd put that as a reasoning as well. So I've put the median for females is higher than the median for males. So the middle female spends more than the middle male. But the maximum male spending was higher than the maximum female spending. The whole question was worth 5 marks. In question 13, Francesco carried out a survey about the ages of people in his office. The table shows information about his results. So we need to draw a cumulative frequency graph for that table. So again, we'll plot the cumulative frequency against the upper limit of each group. So 10 would go against 30, 26 against 40, and so on and so forth. So when you do that, you get this graph here. In the second part of the question, we need to use it to find an estimate for the median age. The median age is going to be at the value which is half of the total cumulative frequency. The total cumulative frequency was 70, so half of that would be 35. So I draw a horizontal line straight across 35 until I reach my curve, straight down vertically, and read off my value of that bottom axis, which is 42. So 42 years old is the median age. In the last part of the question, for 3 marks, Francesco says that more than 60% of the people in the office are aged between 35 and 55 years old. So we need to use the graph to determine if he's correct. So what I've done here is I've found 35 years old on this bottom axis, go straight up to the curve and go straight across. Read off the value there, and that is 16. So 16 people were aged less than 35. Similarly, for the people who are aged 55, so 55 years old, I can see there was 63 people who were aged up to 55 years old. If I subtract those values, that gives me the number of people who are aged between these values. So between 35 and 55 years old, there's 47 people. 47 as a fraction of all the people in the office. Well, as a fraction, it's 47 divided by the 70 people in total, since I'm told there's 70 people in total. And then to turn that into a percentage, I just need to multiply that by 100%. So you can calculate this as a decimal using your calculator and times by 100%, and that would give me about 67%. So that would mean that Francesco is correct, and I've written that as a statement here. The whole question is worth 6 marks. In question 14, I'm given a group frequency table which gives information about the times in minutes that 80 office workers took to get to work. And I need to complete the cumulative frequency table. So all I need to do is need to work out the running total as I'm going down this table. So that would be 5 for the first row, 5 plus 30 for the second row, which is 35, 35 plus 20 for the third box, and so on and so forth. So I'll get these numbers here. The total is 80, and I know that's correct since there's 80 office workers altogether. On the next part of the question, I need to draw the cumulative frequency graph for the grid. Cumulative frequency graph is just drawn by using the value in this box here against the upper limit for each group in this column here. So 5 will be plotted against 20 minutes, 35 against 40 minutes, and so on and so forth. So you get this curve here. In the next part of the question, it says that I need to find an estimate for the percentage of the office workers that take more than 90 minutes to get to work. So 90 minutes on this axis is here. If I go straight up vertically until I reach my curve and read the value of the y-axis, I get 74. So that means 74 people out of 80 take less than 90 minutes to get to work. So that means that 80 minus 74 gives us 6 people took longer than 90 minutes to get to work. So that's 6 people out of the 80 people as a fraction. So as a percentage, times it by 100%, and that gives you 7.5%. So 7.5% of the people took more than 90 minutes to get to work. All the rest took less than 90 minutes. So these people all here took less than 90 minutes. These people, a small portion here, took greater than 90 minutes. The whole question is worth 6 marks. In question 15, I'm given a cumulative frequency table that shows the marks some students got in a test. I need to first of all plot a cumulative frequency graph for that information. So that's given by plotting each cumulative frequency against the upper limit for each group. So 8 will be plotted against 10, 23 against 20, and so on and so forth. So that would give you this curve here. In part B, I need to find the median mark. The median mark is given from the 50% value. The 50% value, since I know that there's 80 people altogether that took the test, the middle value is going to be the 40th value. So if I go across from 40 on the y-axis until I reach my curve and read off the value here, I'll get 27 marks. So that is the median there, 27. In the next part of the question, it says that students either pass or fail the test. The pass mark is set that 3 times as many students fail as pass the test. So I need to find an estimate for the lowest possible pass mark. Well, if I write that as a ratio, failing is 3 times greater than passing. So as a ratio, fail would be 3 parts and passing would be 1 part. Therefore, as a fraction, passing is a quarter. It's 1 part out of 4, which is 25%. So I need to find the 25% of the 80 pupils, which is 20 pupils, and look at their pass mark. So 20 pupils, which is the greatest 20 pupils, which is here, 60, since that is 3/4 of 80. So I'll go across from 60 and read off the value from the bottom axis, which is 37. So 37 marks and above would give you a pass mark. Anything else and you'd fail it, and that's shown here by the majority of pupils here which failed. So this region here is 3 parts and this region here is 1 part. This region here is 3 times as big as this region. This region here represents 20 people. This region here represents 60 people. The whole question there is worth 6 marks. Question 16, I'm given a cumulative frequency graph showing information about the heights of 60 students. I need to work out an estimate for the number of students that are height greater than 160. So here's a height of 160 on this bottom axis here. If I go straight up until I reach the curve and read off the value corresponding with that, I'll get 48. So 48 students had a height less than 160. That leaves 12 students having a height of greater than 160, since there's 60 students altogether. So the answer is 12 for 2 marks. Question 17, I'm given a cumulative frequency graph about the information of the weights of 60 potatoes. So this represents the weights of 60 potatoes. I need to use the graph to find an estimate for the median weight. So the median is going to be the middle value. Since there's 60 potatoes, the 30th potato will be the middle. So we'll go across from 30 and straight down and read off that value. So that is 57 grams. In part B, Jamil says The 80 subtract 40 equals 40, so the range of the weights is 40. Is he correct? On a cumulative frequency graph, this is the maximum weight, so that's fine, that's 80. But this isn't necessarily the minimum weight. We haven't been given any information about the minimum weight of the potatoes, so he isn't necessarily correct. In part C, I need to show that less than 25% of the potatoes have a weight greater than 65 grams. So let's find 65 grams on my graph. So it's this axis here for 65, straight up, and that gives me a value of 48. That means that 48 potatoes have got a weight up to and including 65 grams. So the rest of them must have a weight greater than 65 grams. That means that 12 potatoes must have a weight greater than 65 grams. Well, 12 as a fraction of all the potatoes, since there's 60 altogether, that's 12 over 60. But times that by 100%, I'll get 20%, and that is less than the 25% here. So that question there is worth 4 marks. In question 18, the cumulative frequency graphs show information about the times taken by 100 male runners and 100 female runners to finish the London Marathon. I'm told that a male runner is chosen at random. I need to find an estimate for the probability that the runner took less than 4 hours to finish the London Marathon. So we're talking about male runners here. So male runners is this curve here. And 4 hours would be 240 minutes. So if we go up from 240 minutes, read off the value, and I get 42. So 42 people, these male people, out of 100 took less than 4 hours. So the fraction, that's 42 over 100. And so we want to cancel that down, I just get 21 over 50. So the probability of choosing a male runner that took less than 4 hours is 21 over 50. In part B, I need to use medians and interquartile ranges to compare the distributions of the times taken by the male and female runners. So I need to find the medians and the interquartile ranges. Medians are just given by halving the total cumulative frequency, which is 50, and reading off those values corresponding to the 50th runner. So the 50th runner for male was just over 240, which is about 252, and the 50th runner for female was 276. So there's my median values there. And for the interquartile range, I need to find the lower quartiles, which is given by the 25th person, and the upper quartile, given by the 75th person. Read off those values, and you get 63 and 47 for male and female. I then need to explain what this tells me. So I need to compare in real life. So male runners took less time to complete the marathon than female, since that's what the median shows us here. So they took less time to complete on average. The lower interquartile range for females suggests that their times were more similar to one another. Male runners had a high interquartile range, so they varied a lot more. The whole question there was worth 6 marks.